Modern science would like for you to believe that this is a boat that has sailed over the curve and it's now on the other side of the horizon. This is a video I did of a boat being zoomed out back over the horizon, and watch it disappear bottom up. Bottom's gone, middle's gone, top gone. And people are arguing, saying that boat did not disappear bottom up when you zoomed out. That person was standing on the beach. And Sky Free on YouTube will give you a representation showing you that something going over the horizon or disappearing bottom up is an optical illusion. This is Sky Free's YouTube page. She's got a pencil sitting here at the end of the hallway, and they just open the door, and look at that. Just through temperature, it disappeared bottom up.
We have another observation with the battleship to show you. This time we'll take the battleship to nearly 1,000 feet from the viewer. It was calm on this day at the lake. The center of the camera lens was approximately 2 inches above the water surface. The observation took place between 11:45 a.m. and 12:15 p.m. Here is a look at the size of the battleship we were observing. The tallest point of the ship sits approximately 6 inches above the waterline, and the hull is about 1.5 inches above the surface. And here it is traveling beyond 300 feet. Here it is at around 700 feet. The geometric horizon for a viewer at 2 inches on a sphere of our given radius would be over 2,600 feet away. So there can be no obstruction due to curvature in a mere 1,000 feet. Yet the rate that this bottom-up disappearance of the RC boats occurs across these small lakes matches what is witnessed with large boats over large bodies of water. Hi there. We have a quick garage test to show you. The objects we're viewing are placed approximately 35 feet from the viewer. The center of the camera lens is 1 1/4 of an inch above the surface. During the peak of the test, when the garage door was open to about 2 feet above the surface, the temperatures cooled, with the surface temperature cooling the most. Here are the objects from the viewer's perspective at the start of the test. And here we open the garage door a bit. Notice how the objects appear to sink, and the green object is no longer visible. The laser pen is placed on the surface less than 14 feet from camera 1, our older camera, which has the center of its lens around 1/8 of an inch above the surface. Camera 2, our newer camera, is set looking at a square tin bucket with the laser light focused on one side. Here is the laser pen from camera 1's perspective as we open the door. As we often see, the object appears to sink. Here we open the door. And here is a look from start to finish with the footage sped up 8 times. We waited a little over a minute for the air to settle, but even then, the light hadn't settled back to its original position. There was still displacement occurring when we stopped recording the first test. Here is the light at the start of the test again. And now at the end.
So he took the data from the internet and built all the layers of the atmosphere, and suddenly the magic happened and everything started to make perfect sense. And when I say everything, I mean everything.
With 3D software, you can model the atmosphere very accurately using refraction settings. We're not talking about drawing it and making it visible, we're talking about drawing the layers with their real effects on sunlight. Once I discovered it, I told my team, guys, we've got a solution. We can test the atmosphere's effect on the light.
After we had everything fixed, we started to compare it with real life. We actually took some real sunset videos and compared them with both the flat earth model and the globe earth model. And guess what? If you play the 3 videos at the same time, you would not know where the flat earth model is, because it really looks like real live videos.
Many scientists think that the flat earth model can't work because it can't represent sunrise and sunset. What are they going to say after studying this proof? Is it going to make sense to some of them now? They can't ignore the atmosphere, and all we did to make the flat earth model work was add the atmosphere exactly how science represents it.
People misuse the word vanishing point, and here I will prove how it works. The first concept is air density. Have you ever driven on a foggy day? You can't see 2 feet in front of you sometimes. Or take this example of the Chicago skyline from what should have been an impossible 40 miles away. Some people ask, why the buildings are cut off. But isn't it obvious? Here you can see a cloud of air. What they should have asked themselves is, why can you see the buildings at all if the Earth is not flat? Now, what is very important to understand is, air compounds. Every mile, there is more air to look through. This forms a gradient. When we put several sheets of clear plastic in front of the other, they form a wall that you cannot see through. The atmosphere is filled with oxygen, zinc, carbon, hydrogen, and many other chemicals that forms a wall of density. Let's watch the experiment in action. As you can see, the sun gets cut off from the bottom first. But that's not all. There's many things to discover in this experiment. First of all, you can see the light shrink around the sun as it sets. This is exactly what we see in real life. When the sun sets in our experiment, we see a color change, just like real sunsets. One major difference in our experiment is it's on a small scale and it's low budget. The advantage is you can do this yourself at home. We will now compare to the horizon you see daily, but before we do, we want you first to understand perspective. As you can see, things that move to the horizon get smaller and lower. However, the appearance that they are getting lower is just perspective. You prove this by looking at a long hallway. The altitude of every light in the hallway is the same, right? Some people think, in the flat Earth, that when things hit the horizon they diverge due to optics. And although that's a very interesting idea, we're only working with logical things that we can prove in an experiment. With air density, you can prove sunsets without fancy diverging lines, however true they may be. You can see in our experiment we have lower atmosphere, middle atmosphere, and high atmosphere. Did you know that the air gets thinner as you get higher? This is because of buoyancy. You see things that are less dense separate from things of greater density. This is why clouds float, this is why helium balloons rise. This forms a vertical gradient and gives us a horizontal and vertical air gradient. In fact, the speed at how fast things fall depends entirely on buoyancy. If you drop an item in the water, it falls much slower than in low altitude air. If you fall from a high altitude, you fall faster. When you jump from air into water, you fall fast and then slow. This is about a 10 to 20 mile high wall of air. Also, remember there's clouds as well blocking you in the way. Remember the buoyancy idea? Well, the high altitude air is thinner, so the wall is a little bit further. This is why the sun changes colors before it sets on a clear day. It gets blocked by the buoyant air, and then its bottom is cut off by the heavier air. Now you might be thinking, can a 10 to 20 mile high wall of air seriously block the sun when it's thousands of miles away? Well, of course, and here's a diagram of exactly what you're experiencing. You can see the observer and a line drawn to the horizon. The sun gets cut off when it's thousands of miles away. This isn't to scale, but you get the idea. You can even do the math for this if you like. Draw a triangle, imagine the horizon line vanishing point is about 50 to 100 miles away. Then you will see, even if the sun is high, it will fall into the horizon. In our experiment, what you won't see is how dramatic of an effect the air has on the sun. It tends to dilate the sun's diameter. This is why when you see a sunset, it doesn't shrink as much as it should. It does shrink, but it also dilates. Let's look at ships on the horizon with this refreshed perspective. What density also affects is the water line. Look at this diagram again. Did you know that the air above the water is filled with more water vapor? Well, of course, right? Buoyancy. So that may not seem important, but it's of huge importance in optics. Imagine if I used these blue gels instead of transparent gels. Would you be able to tell the difference between the water line and thousands of these gels stacked together compounded over many miles? Let's look at some examples. You can see here the boat is almost invisible. Here, the air almost completely blocks it. From far away, this air is dense with water and even reflects the water below. This higher waterline effect can cause boats to not be visible and even cause a slightly higher waterline occluding the bottom of buildings and beaches. Remember, over the ocean, there is waves too. The water in the air sometimes causes a sparkling, wavy fractal pattern when you zoom in on it. This is why using examples such as the Bolivian salt flats, Mount Everest, and other land examples are in some ways better for proving that there is no curve. Since you also need to educate people on compounded water vapor. And for further research, you should look at converging and diverging lines of perspective on the horizon. Perhaps we can consider the curvature of the lens of our eye and even a camera lens as well to play into this. The sunset we see on the Earth matches one on a flat Earth because of the diameter change of the sun, the shrinking light of the sun, and the sun's path in the sky. However, there are already so many videos debunking a round Earth and proving a flat one, and if you have seen this video up until this point, I would love it if you would do more research on the subject. When searching for the truth, it doesn't matter if the world disagrees with you. If you are right, and the truth will set you free.
the bottom will disappear.